About this. Well, thank you all for attending. Again, I'm Ryan J. This is my final day as part of the Red Hat team. So sorry about the roughly prepared presentation, but hopefully this gives you a good introduction to what I mean by application. I know in the Kubernetes world, application has been kind of a term that's been avoided by various groups. I know at least within the OpenShift engineering team, they're very hesitant to put this term into documentation because it's often subjective on a variety of factors. What you mean by application may depend on whether you're a developer or an operations person or an architect or on particular stages of a release pipeline or on different environmental config or a variety of other factors. So if you wouldn't mind switching to the right, we should be on a slide that says define application, with a short equation here that I've kind of put together. So this is kind of super high level how I would define very discreetly what pieces go into a application in the Kubernetes space. So the first part of this equation, I have the letter O here for my raw Kubernetes API objects. Next, I have a letter C, which stands for configuration. This is something that should be probably merged into your list of API objects and are going to be subjective depending on what you're deploying. Next, I have an I for images. If possible, you may be able to define a set of objects that produce your images, or you may have images that are kind of defined as part of the provisioning process. You may create a deployer image that runs a build and then produces a application image that is then shipped. Right. So images are somewhat tricky to define because they may have a delayed resolution in this type of equation. Next, I have this is all dependent on this letters S, R, and E in the equation I have here. So you have a S, I think of as my stage. For me, a stage is one link in your release pipeline. And hopefully what you are shipping as an application for a dev stage may include the support for developers to iterate on a solution. For your production stage, you're probably going to want something stripped down, minimal attack surface. All the dev tools have been stripped out. You have something really minimal and clean and lightweight for production to optimize for a higher density. Another factor you're going to have in this equation is availability of system resources. And lastly, there's always some amount of effort involved, whether it's operational and maintenance effort. You know, some of this you can automate, of course, but there's going to be people kind of rebalancing this equation at various points in your release process. Architects who may be figuring out which is the appropriate config to inject, or which is the appropriate base layers of a system image to standardize on and have developers reuse those base layers, perhaps. So any questions about this slide, the defining application? Does this make sense for most folks?
I think it did, but it doesn't without explanation, because when I see OCI/SRE, I see Open Compute Initiative / Site Reliability Engineer. So I'm like, I don't need to pay attention to this. I know what both of those are. And then you went to explain it, and I'm like, okay, this is entirely different. Without explanation, this can quite easily become confusing.
Yeah, so what should be working, and sorry if you can't see this, I can't even see what's happening with the screen share right now, so I'm not exactly sure what you're looking at. The definition page, if you hit down arrows, I've been iterating through each of these. So there should be kind of a point by point how I define each of those terms. So hopefully, and I tried to link through to other pages in this deck of slides from these. I think the human effort doesn't have a corresponding link, but those are kind of my 6 pieces of how I would define. And yeah, OCI, SRE are kind of could be confusing. I could have rearranged it, but figured I may as well make things extra challenging for you guys to follow, right? So let's hop one page to the right, and I'll kind of flip down through kind of introducing, if you're not familiar, OpenShift is basically a set of extensions to Kubernetes, not extensions in the third-party extension sense, but they are additional object primitives and features that are layered into Kubernetes. We try to stay pretty true to the upstream Kubernetes code base because Red Hat's a pretty big contributor. We try to push a lot of changes into that core code base. And as you scroll down through this deck of slides, I go through some of the differences and feature set that OpenShift adds, and a list of object primitives that you might find useful. Most of these I kind of briefly mentioned this list of object primitives, including a couple unique object primitives that are non-standard or not available in the kind of core Kubernetes community feature set at this point. The features that I think are particularly relevant for OpenShift users and some kind of unique things that we may see land in Kubernetes at some point really depends on what the scope of Kubernetes, what Kubernetes really intends to address. From my understanding, it sounds like most of the core maintainers kind of envision Kubernetes as primarily a operations tool where folks have already built an image and via some process, whether it's Jenkins or a variety of tools, and now they want to deploy that image in across a Kubernetes cluster. So we have a couple features that help make that process more iterable and give more kind of touch points for developers to interact with. So there's something called a deployment config and a build config. You scroll down through the object list, you should see some brief kind of pages calling out what those objects are and how to use them. All of this, the last bottom of this vertical should be links to both the Kubernetes docs for more information on the official source for these object primitives, and to the OpenShift docs for primitives that are not covered as part of the core feature set.
I would actually point out too, to Ryan's point, deployment config is actually what deployments is based on some of the original discussions we had at the very beginning of Cube, where Brian and I agreed that we wanted to add deployments to Cube, but it wasn't going to happen for Cube 1.0. And so what we did on OpenShift was we took the core idea, prototyped it, built it out, integrated it with the idea of images and being able to define, to solve the problem of when I run a build that builds a new image, how do I roll that out automatically to everyone in my cluster? And so a deployment config is like a Cube deployment, but it can be triggered based on images. And it also handles things like hooks, right? Because when real applications go and build deployment configs, they have hooks that let you initialize the database or talk to a load balancer and run custom tests on it before you actually give it the go-ahead to let the deployment, quote unquote, succeed. And so these are all features that we've put the core elements of in Cube, right? The deployments feature in Cube is like a subset of what's in deployment configs. And the goal over time is to get all of those features into Cube so that we can do things like have a generic trigger controller that might let you do things like webhooks that trigger new deployments, or let you be able to run hooks or have deployments that quote unquote fail, so that if the deployment fails, it cleans up any mess, and then you can go say, hey, wait, my deployment's failing because of my code change. Well, I need to go fix that before I push a new build and update the code again. So a lot of these concepts are core Cube concepts that we implemented in OpenShift first, and then gradually moved the pieces back into Cube, and we'll continue over time.
So, Clayton, is there anything that y'all are working on currently? Any of these features that are in deployment config that you want to push upstream? It's like kind of really high priority or something that's active in development right now?
Yeah, so there's a bunch of PRs open. We've had a bunch of proposals open for quite a while that have been discussed, and some of this was being covered in SIG config, but I think belongs in SIG-Apps now, which is the idea. So Perm fail deployments are a big one. If a deployment tries to roll out, at some point, instead of just keeping and trying forever, you may actually want to give up and flag an error that a higher level, an admin can see, oh, my deployment failed. Why did my deployment fail? And because none of the new pods ever became ready or something like that.
Okay.
The trigger controller is something that I think we'd like to have a generic idea of. That would be something that watches for changes in other systems and then updates the deployment so that it has the latest image from a remote URL, or when you hit a webhook, you can post a value to a webhook that updates the deployment. And then there's one more. The hook stuff has been discussed as well. So I think it would be good maybe in a future SIG-Apps meeting to go over some of those, since deployments don't really have a home SIG right now. I think SIG-Apps is the best one for them.
Mm-hmm. So I just have one last question, if it's okay. The trigger system, is that something like you would watch for, CI, you would watch in CI system? Is that how you would integrate?
Yeah. And today in OpenShift, and Ryan pointed this out a little bit, the idea of OpenShift has an integrated Docker registry that integrates the metadata that tracks what gets pushed and pulled from the Docker registry is actually materialized as a Cube API object or a Cube-like API object. So as a Cube consumer, you can tag an image from GCR into your local registry. And then the local registry kind of acts as both a smart proxy, and so that once you tag it into the local registry from any node, you can go pull that image securely without having to know what the credentials are to GCR directly or copy those out. And then if you push an image to the registry, it actually triggers a Cube watch event, just like when someone updates a deployment today. If you're watching that deployment, you get a notification through the API. And an image, because the image streams, which is what we call them, are Cube objects. When a new image gets pushed, we update the image stream because that image has been pushed into the registry, and that triggers anybody who's watching that. And so our deployment configs can watch for changes in image streams. So when someone pushes a new version of Node.js, the image stream says, I've changed, and the deployment config is watching for changes to the image stream and says, oh, a new image is available. Let me update the deployment config to point to the latest image, which then triggers a rollout. And if the rollout fails, it rolls back to the previous value. So it's kind of that flow from builds to images to deployment configs is kind of the heart of OpenShift.
Gotcha. Okay, thanks for that. Ryan, I apologize for...
No, that's great information. And some of those pieces, like the build config, you might only want to include in your development stage. In the production stage, you're probably just going to be deploying off of a particular tagged image, and possibly using that image stream primitive as a notifier to trigger that deployment. And then you can have that deployment happen automatically whenever your CI system applies a particular tag into the integrated registry, or you can manually apply that tag to kick off a deployment notification, a notification that would start a deployment process.
Gotcha.
So the next slide I have here, if you hit over to the right, we should be on a page that says templates.
Yep.
And the idea here is just being able to quickly throw together multi-service solutions. I have, if you hit down twice, there's a link to a slightly outdated issue in Kubernetes, which has in the last month recently, or last couple of weeks, recently been closed, but it also has some follow-up information to the official proposal and a new image that's been opened to kind of carry this effort. So feel free to dig in on those issues. I have some more links a little bit later. If you hit down again, we should see a page about OC new app examples. So OpenShift has a command line tool called OC. It's basically a wrapper for kubectl or kubectl, kubecontrol, however you say it. So if I do OC get pods, I should see basically identical output to what I would see with kubectl get pods. The only difference might be that I think for builds, which those build config objects that are a non-standard object, will actually output a pod that has already finished its build results in the command line output. When you ask for get pods, you may see some pods that have already terminated when you're asking OpenShift using the OC command line tool. I have an example of this in a follow-up video that I'll link to at the end. But you should see, if you wanted to deploy just a raw image from Docker Hub, the first example I have in the OC new app example shows the OC new app command with a reference to a image on Docker Hub. This command has kind of a lot of magic, a lot of perhaps too wide of a scope of different things it handles, but it's our quickest way, I think, for generating raw API object structure. And what I've added onto the end of this command is a -o JSON flag. You could also do -o YAML or leave off the -o entirely. The -o will print the generated object primitive list to standard out instead of attempting to post it to the API. Any question? Or go ahead, Glenn.
I was gonna add into, like, I think one of the challenges with Kube today is that we don't have a great way to extensively bring in new chunks of API. And so that's something that there's a lot of focus going on SIG API machinery, that if people are interested in, people who create APIs that they want to work well with Kube, this is something we're actually trying to, like, we've kind of put some of the base stuff in with API groups, and if anybody's run Kube control recently, you start seeing things like petsets.apps, which is groups of APIs that are brought together by Kube so that you can extend to Kube. And a lot of the work that's going on in API machinery is to kind of get to that point where we can start, if someone wants to consume builds or consumes an image repository or consume some of the other features that people add in the ecosystem, like directed graphs or workflows, that it's really easy for someone to take and run that on Kube as an add-on. Today, our add-ons aren't really API add-ons. They're more things like Elasticsearch and metrics that run on top of the cluster, but they don't really expose an API that cluster consumers can really play around with and use.
Yeah, and some of the output of the object list here is going to have things in here like deployment configs and build configs, which might not be portable to other Kubernetes environments. I guess that over time we'll probably see the output of this command produce things that are more standard, or produce maybe abstractions. If they're non-standard, maybe they'll be available as third-party extensions or something that's easy to layer on top of the core feature set. Two more examples I have here on this page are you could run OC new app with a directory path. If there's a Docker file in that directory, that'll allow you to schedule a standard kind of Docker build. This might not be available in the OpenShift developer preview currently. I'm not sure whether that functionality is available, but it's definitely available if you're running your own OpenShift cluster. Another thing that's really nice, if you like having a operations team that focuses on since Docker is a layered file system, Docker images are a layered file system. One thing that OpenShift provides is the capability for operations teams to work on standardizing those base layers and allowing developers to quickly reuse a standardized base image, layer their repo code on top, and then run a very lightweight kind of web build all in user space without handing over root permission or access to the Docker file to your Node.js developers, who I love, but I don't know if they should be going in and changing core parts of the base system images, right? So I have an OC new app example that shows a reference to a base image and then a tilde operator and then some repository code. So that's very easy to take two pieces. And that's first argument before the tilde could be a image from Docker Hub, including a release tag and other details. So all of these examples here, I've used this -o flag so you can see the raw data first. But if you leave off the -o tag, you should immediately instantiate these objects in the Kubernetes API. Another option would be to pipe all the output to OC create -f with a standard in flag at the end. So that should be the last on the new app examples. Next, I have a little section about where OpenShift templates come into play on this. OpenShift templates are another abstraction that the Red Hat team has been working on. We linked to that issue, GitHub issue earlier. There's a couple additional command line flags you can use to help work on these templates. So if you have basically what a template looks like, I should show you an example. There's a OC, I'll get to the example right after this slide, I think. There's a OC process command that allows you to take a template and then inject some key value parameters into this template list. So there should be a example for template processing where you could run OC process -f and then have a -p flag with some one or many key and value pairs. You can also run OC process, pipe the result to OC create to instantiate those objects right away. Another thing you can do is you could run OC create on one of these template objects to install it into OpenShift. This makes the template available in our web console. Makes it very easy for end users, whether they know anything about Docker or development at all. They can just click on a link that says, launch me a WordPress or launch me a Drupal site. And the template has already defined exactly what goes in to that Drupal site, but allows some parameter injection so people can tailor that deployment or that whatever's being produced per stage of their pipeline or per available set of system resources or on a variety of other factors. So the last slide in this vertical deck is a reference to a GitHub repo where I have a Node.js front end, a MongoDB backend, and kind of a full template with some support for parameterization. So I'm going to click on the GitHub link. And if you scroll down to, if you look at the very top of this, you'll see a manifest. It's a standard kind of Kubernetes object format. It's version data. It has a type of data. There's a metadata up top. And then you see a standard object list. This is going to look really, really similar to just a raw object list data type for Kubernetes. Feel free to browse through this raw data if you like. The main point I wanted to show to you is that there are some parameter injections in this file. There's some kind of $ curly brace and then some keys that will be injected. And if you look down at about line 363, there's a list of the available parameters. So each of these parameters has a name, a value, or should be a default value and a description. The default value isn't required, but this gives you a really easy way to init some of these, or give some same defaults to your templatized solutions. You can also, it looks like around line 388, I've got the MongoDB user is being generated via an expression. So we'll use the letters USER and then 3 characters from the alphanumeric range in order to generate a pseudo-random user ID and password for each time this template is invoked. So I can have many users spinning this up and feel relatively secure that they're not going to have each other's usernames and passwords and other details. Any questions about this?
Hey, Ryan. It's 10:31, so I just want to let anybody who needs to leave, please feel free. This will be recorded, but Ryan, feel free to take a few more minutes to continue and
wrap it up. Okay.
Yeah. Thank you.
Yeah, thanks for the time warning. And sorry about the display difficulties. I have a little bit more information in the next vertical swipe, but I think I'm going to...
okay. Yes.
Is that any questions? So if you hop over to the right 2 columns, there should be my templating takeaways.
Yeah, there.
Okay, cool. I'll just try to wrap it up from there. So there are plenty of alternatives in the universe for templating your solution. You can use Helm charts. You can use KPM. You can even just use standardized templating solutions that have existed for many years, like Jade or Jinja 2 or other solutions to generate your list of objects. And my other major point here is the main goal, regardless of what templating solution you use, you want to be able to quickly and efficiently resolve everything down to a raw list of native Kubernetes object primitives as easily as possible for a particular pipeline stage. And like I said, you may need to tailor this information per stage of your pipeline, whether you want to be able to iterate on these solutions as in a development stage, or whether you need some extra test automation as part of what composes that stage. You can package up kind of per stage a lot of this information. I have another slide about ways to try OpenShift. If you are interested, we have an official developer preview of our Kubernetes-based OpenShift available. Also, one more to the right after that, I've got a list of free O'Reilly ebooks, courtesy of Red Hat. If you're interested in any of these ebooks, feel free to download all of them if you like. We've got one on OpenShift for developers, one on Kubernetes, one on Docker security, and lastly, one on microservices. Next slide to the right, there's a couple follow-up ways to get involved, the ways to hear more about what we're working on. And if you have any questions, feel free to post it into the SIG-Apps channel, and I can add additional links to these slides. Any follow-up questions before we close here?
Can you drop a link to this deck into chat here so everybody can get it?
Yeah.
I know it'll be meeting minutes, but it might be nice to just have it here.
Yeah, it's already in the SIG-Apps channel, and
right.
There should be a link all the way on the, grab the link from the front page. It's bit.ly/sig-apps-OpenShift.
Yep. All right, I see it, yeah. Okay. And it'll be in the meeting minutes, just so, because there's a lot of links in here, and it's nice to be able to click through those.
Yeah, definitely. I wanted to give you lots of take-home information. Another, if you want to see a video of walking through a lot of these concepts, on the very last page, there's a link that says OpenShift booth demos from OzCon. That's about a 15-minute demo where I walk through exactly how we iterate on images, how we do our deployment automations, how we set up webhooks from GitHub so that anytime there's a change in a external source repository, we automatically rebuild and redeploy in order to continue to maintain the definition of what is an app as it changes over time.
Okay. Yeah, you know, one thing that this whole thing brought to mind, and somebody correct me if they disagree with me on this, is I noticed Red Hat doesn't have a Kubernetes distro of its own, but there's OpenShift. And when I see this, I say, you know what? What you talked about today was things that make building and deploying applications into OpenShift easier. And so part of me is wondering if it's being said without being said that Kubernetes by itself for app developers and operators isn't sufficient. So we need to add these additional things because it just doesn't have what's needed there. There's a gap in that space. And I know I personally feel that when I look at Kubernetes itself, there's just gaps there.
I think it's the core team is really trying to focus on what is Kubernetes, what's the purpose of this tool, who are the users, and I think they want to save it from feature bloat and from expanding in too many different competing directions at once. And so my understanding is that the initial purpose, for now at least, is it's an operations tool. And if these features are going to make it into core, they need to be most likely implemented as extensions, kind of how Red Hat has done. And then the community can go and debate the merits of, you know, does this extension belong in core or not? And the more we convert these into third-party extensions and things that are easily pluggable and layerable on top of a standard Kubernetes base, the more likely they'll be considered by a wider audience and vetted and perhaps argued that, yes, this is core functionality and Kubernetes is not just an operations tool, but it's a DevOps tool that does both, right?
And I want to add to that, like, this is something we struggle with. OpenShift was a platform prior to Kubernetes, and so we knew that there was a bunch of use cases that we wanted to keep working as well as possible. And you know, the idea of developers being self-service, just like Heroku and some of the early platform as a service, it's a very easy push button, have source code, can deploy app. And we wanted to preserve as much of that as possible and kind of sketch out a direction for what that would look like on top of something that's much more powerful and flexible like Kubernetes. So, you know, all the power of Kubernetes and pet sets and daemon sets, but not the, but have that kind of easy use use case for developers who just want to push code and try to bring those two together. And also very early on, we needed to add security features to Kubernetes that we agreed jointly, you know, early on at the very beginning of the release that, or the very beginning of Kubernetes, that it would be too fast, too much too soon to try to rush every security concept into Kube. And so OpenShift is a multi-tenant Kubernetes platform today. So a lot of the security stuff is gradually we are introducing it in bits and pieces to Kube. And it kind of was in a spot where we're happy, as Ryan said, to build extensions and to try to work these into the community in a way that's an open and transparent thing where we add a feature and everybody agrees that it's valuable either in core or as an extension. And for now, OpenShift is Red Hat's distribution of Kubernetes, and our goal is to just make it so that it's obviously a set of extensions around Kube than today, where you know many of these things are packaged with Kube because it's the only way to get you know full multi-tenant security for pods, for instance.
Yeah, important. Yeah, good details. Any other follow-ups, or should we wrap it up?
Yeah, I know we're past time, but you know, take some time to ask questions while we have Ryan here and Clayton on the call. Don't be shy. Okay. Doesn't seem like there are more questions, but I'm sure that people will reach out to you, Ryan, if they have more questions. Thanks so much for talking to us today. And thank you, everybody else, for your patience with the technical difficulties. And next week we have some fun stuff on the agenda. They might change, but the tentative plan was a Helm presentation, but we might also have some discussion around pet sets. I know we want the SIG to be more involved with pet sets, so please join us for that. And also we'll have a quick demo of NanoCube by Mike. So join us next week, and thanks for coming.
Thanks all.